Our last topic in statistics is on linear regression. Now, you can have two sets of data that correspond to each other in some way. Here I have a set of data which is the years of the 1990s and the population of the United States in millions. Sometimes your data sets can be over time, a span of time. Sometimes it don't have to be with time. It could be, any two sets of data could be a person's height and their shoe size, for instance. That's two corresponding sets of data. Now, if you have two sets of data like that, they could correlate to each other in a series of different ways. In fact, I would say 4 different ways, and you could vary this a little bit as well. There's positive correlation. That means as one variable increases, the other increases in a steady rate. There's negative correlation, so as one increases, the other decreases at a steady rate. There's nonlinear correlation, which means there's maybe a pattern, but maybe there's some change to it. As one increases, the other might increase, then decrease, then increase again, who knows? Okay, or some sort of curve where it's increasing at a gradual amount and then very quickly later on, or something like that. And then you have no correlation, where it's just a bunch of dots on a page and there's not really any organization to it or rhyme or reason to it, okay? So those are some options. So let's take a look at what positive correlation looks like. If you had the two sets of data, essentially you're getting ordered pairs. You're combining these, you get a point like an X and a Y coordinate, and you can plot those points on a graph, okay? We call those scatter plots, all right? Scatter plots for a positive correlation are going to be, they're going to be a bunch of dots that tend to have a linearly increasing trend, okay, a very steady increase, right, over time or over whatever the horizontal and vertical axes are here. Doesn't matter if it's time or not, but throughout the duration of their relationship, it's going to be increasing steadily. A negative correlation, you would have some sort of negative linear correlation where relationship, I should say, where it's decreasing, the points are decreasing at a relatively steady rate. If you had a nonlinear correlation, there might be some sort of pattern, but maybe that pattern has some sort of increase followed by a decrease, followed by another increase. Could be a lot of different things. Could be maybe I'll do another one here. Could have some sort of a change in the rate. Maybe it's always increasing, but it's increasing slow and then goes, increases very quickly and then maybe levels off again or something. So there's variety in what the correlation could look like or what the scatter plot could look like. And then of course there's no correlation at all. And no correlation could be, again, a variety of different things, but it's just dots. No real pattern to it, okay? We're really going to focus in on these first two, and a little bit on the last one as well. The nonlinear correlation is important, but it's not really going to be part of what we're talking about with linear regression. It is a possibility. It does show up in very, very useful and practical applications, but we're just not going to deal with stuff that isn't linear because, well, we haven't dealt with linear or nonlinear functions in this course. Okay, so anyway, let's look at the positive and negative and the no correlation. And let's take a look at this set of data in particular and see what happens. Before I do that, actually, one other thing is there's something called a correlation coefficient. Maybe I'll write this up here. And we use the letter R to represent the correlation coefficient. It's a measure, it's actually a statistical value that can be calculated either by hand or with technology. And it's a measure of how tightly, that's a word, tightly, the data fits a linear trend. okay? It could be really nice and very linear like this one, a good positive correlation, or you could have a positive correlation, but you can kind of tell there's a positive correlation, but it's not a real tight, linear looking correlation. Things are spread out a little bit more. Maybe it doesn't quite have as obvious of a trend to it. And that's less of a positive correlation, but still a positive correlation. Well, this correlation coefficient can give us a better understanding of how well the data fits a line, or a line fits the data, however you want to say that. And so what happens is the correlation coefficient is a value. I'm not going to give you the formula or have you calculate it itself. It can be found on your calculator, but I'm not too worried about you actually being able to find it, maybe using it if you had it, or estimating it if you were given a graph, just a general idea. But basically this value of R is limited between values of -1 and 1. So the correlation coefficient is any decimal value between -1 and 1, 0.95 for instance, or 0.12. Those are possible correlation coefficients, positive or negative, or 0 even. And the closer that value is to 1, the better a positive correlation you will have. Okay, so if you're at like 0.98, if R is 0.98, that's going to be a very close, a very tight positive correlation. If it's like 0.1, if it's closer to 0 but on the positive side, it's going to be a less defined but still positive correlation. If the R value is negative, you get a negative correlation, kind of makes sense, or negatively sloped trend. And the closer the R value is to -1, again, the tighter that trend is going to be to a line. The closer that R value is to 0, but still on the negative side, the wider that dispersion, but it's still going to have some negative trend to it, okay? And of course, the closer R is to 0, the closer, the more likely you are to have no correlation, I suppose. Okay, so it's just going to be dots on a page. So that gives you a little bit of a idea of the correlation coefficient. Okay, so now let's look at this actual data here that I have on the board. I'm going to get rid of some of these graphs, maybe just a couple of them, just to clear up a little bit of space here. So you can actually come up with a scatter plot. If I were to present you with some data, you could come up with a scatter plot and then make a judgment about what type of correlation you have, and maybe get some sort of idea of what the correlation coefficient would be. Or if you were to get a correlation coefficient, you could match it up to a graph. Okay, so let's take a look at those options. With this particular set of data, I'm going to go to my graphing calculator. Now, it's useful in many cases to alter the data, sort of. I've already done that in a sense. I've taken the population and turned it into millions of people. So this is 249 million. This is a rounded number, obviously, but if I were to not turn it into millions, it would be 249,000,000,000. But that's just a lot of extra things to type in and have to keep track of. So we just chop it off and say these are the number of millions of people. Okay, now the years, you could do something similar. So for our x values, we're going to have x values here, y values here. That's going to give us our ordered pairs for our points, right? An x and a y correlation there, or combination there. So what I want to do for the years is, instead of using the full 1990, 1991, I'm going to go with 0, 1, 2, 3, because the 199 is all the same all the way down. And so if I just go with, if I define x to be, let's say, the number of years after 1990, right? Let me define it over here. X is number of years after 1990. Well, that means that 1990 is year 0, right? X value of 0 1, 2, 3, and so on down to 9. Okay. And so that's the value that I'm going to plug in for my data. For purposes of this, it doesn't really matter. I could put the whole thing in, but just to ease our burden of typing, we'll go with that. So what I want you to do, and I'm going to give you some instructions on this, you're going to turn your calculator on, the easy part, and then you're going to use the stat button. Okay, so this data, first of all, the data needs to be entered into the calculator, and then you can create the scattered plot. Okay, so to enter the data, you go to your stat button. Yeah, that's the one. Right underneath the delete. And you're going to get this menu. There are actually 3 menus. You have an edit, calculate, and tests. These are different features. I think we've talked about this actually in another video. These are different features or different menus that you can use for analyzing statistical data. We're going to go to enter and hit enter. Okay, before I go any further with that, let me write these instructions down. So the first thing we're going to do is to enter data. And to enter the data, you're going to go to stat first, the stat button. You're going to use the edit menu, and you're going to click on the first option under edit, which is edit. Sounds a little redundant, and it is, but that's what we do. At that point, that's where I'm at right now. You're going to enter your data where the X values are your list 1, L1, and the Y values are L2. Now you can use other lists, you can store lots of data. This actually, you can keep clicking over and you get more and more lists, but I'm just going to stick with the first 2 here. And you can see I pre-entered these just to save some time, but if I scroll down, you can see how the data keeps going, oops, and then it jumps to the end. There it is at the bottom. And always want to make sure that the data matches at the bottom. It's very easy to skip over something, and then if they don't match at the bottom, then you're going to have some problems later on. Okay. All right. So we're going to enter data. I'll just type, write this in. Enter data in L1 and L2. All right. List 1 and list 2. Then you're going to hit the second and then the mode button to quit and go back to the home screen. Okay, so second mode gets us to quit, which is the home screen. Okay, so that's a good start. That gets our data entered. The next step is to actually form the scatter plot. Scatter plot. All right, now this one's a little bit different. You don't go to stat. Instead, above the Y equals button here, there's a second feature called the stat plot. You hit second and then the stat plot button. Okay, so second and then stat. Oh, second and Y equals. I'm sorry. I should rewrite that. So you hit second and then the Y equals button, and that takes you to stat plot. That's better. Okay. Once you're there, we're going to select the first plot. Now you can do a lot of different plots. That's why they give you a lot of lists in there if you're comparing data or you want to look at multiple different sets or you're storing things. Whatever the case is, we're just going to use plot 1. So hit enter on plot 1. And then you're going to get this this screen where you have to select some features. First thing is we got to turn it on. So you hit on while it's flashing. The rest of this should be already set up, kind of defaulted. The first little box here, the type of graph is a scatter plot. You have other types of statistical plots. There's box and whiskers, histogram, line graphs, so lots of different things. But we want the scatter plot. Then you go down here and it wants to define what the X and Y are. We're just going to use L1 and L2. You don't have to worry about that. If you ever needed to change those for some reason, the L buttons are the second feature. You hit second and then the corresponding numerical button, and that will get you an L. So L3, for instance, is second and then the number 3, and that'll give you the L3. Okay. And then the mark at the bottom, this is what the point will look like. I like the little box. That's what I'm going to go with, but you could use a plus or a dot, however you want it. I like that because it stands out nicely when I plot the graph. Okay. All right, so we're going to turn on, and then we're going to set up the rest of these features, I guess. I don't know how else to say that. Set up features. They usually are already done for you if you don't edit it or change them. All right, and then we want to get this to actually plot on a window. The window we're going to use is under Zoom. Zoom gives you some sort of predetermined windows, okay, for our graph. And so if we go to Zoom, a real convenient one for this is called Zoom Stat. Now it's not on this first screen. You actually have to scroll down until you get to the 9th option down. Where am I at? Yep, there's the 9th one. Zoom Stat, okay? So I'm gonna hit Zoom. Then the 9th one down is Zoom Stat. Okay, then I'm going to hit enter on that, and it's going to give me a graph. That's a scatter diagram right there. Now it automatically adjusts the window to match the data. Okay, so it's got basically a predetermined way that it figures the window to make sure that all of the minimum to maximum values within the data are covered in each axis, okay, with a little bit of buffer on each end. So that's kind of nice. It may be the case that you don't want this window for whatever reason. You can always adjust the window by going to the window button, and then you just type in specific values. You can change your X minimum, X maximum, the scale, which is the number, the space between the tick marks, and then the Y max, Y min, and the Y scale. All right, I'm going to go back to graph. There it is. And now, based upon this image, you could determine, or I would, that there's a very good positive correlation. Okay, it's very linear, and it's pretty obviously positive based upon the graph there. Now, it may be a bit of an exaggeration on how steep that is because, of course, we've trimmed off a lot of this data. This window, I didn't even look really when I had the window screen on. I don't know what the minimum is here, but it's likely that there's a lot to this that's not being shown. And so if you were to actually look at the entire XY plane, you might see that this increases, maybe not quite as dramatic as what it shows on the graph. But either way, it's still positive, and it's still apparently very linear, okay? So I'm going to say on this one, we have a positive linear correlation. Positive correlation or linear. And that means R is near positive 1. Okay? So we can assume R is going to be a value close to positive 1, 0.9 something, 0.8 something. It's going to be in that ballpark, probably somewhere between 0.8 and 1. Okay? Maybe 0.9 and 1, depending upon how tight that really is. Again, I'm not going to make an actual estimate. I'm just going to get an idea for the R value of what that might be. Okay, so this gives you an idea then how to enter the data, how to set up your scatter plot, and how to kind of look at your correlation coefficient. Now, you can actually, and we're not going to do this in this class, but you can actually calculate a line that best fits the data. There is one particular line that fits this data better than every other line. Obviously, you could draw a lot of lines in here that are close, but there's going to be one particular line for every set of data that will be the best one. It's a complicated process to calculate those by hand. Your calculator does a good job of that. If you ever needed to do that, it's under the Stat button again, and you go over to Calculate, the Calculate menu, and you go down to the fourth one. Am I on it? Yeah. The fourth one is Linrec, linear regression. It has an AX plus B. You can kind of see in the parentheses there. AX plus B is kind of your slope-intercept form. It's kind of like Y equals MX plus B. They just use an A instead of an M. All right, so that's your slope. The A is your slope, the B is your y-intercept. All right, and so you can do that. You can, and it will give you. Oh, I'm stuttering. It can give you a actual linear equation for the line that approximates that data, and there will be one that's best for any data set. Okay, and then of course you can use that line or that model to estimate things like future values. It may be off, right? The points don't always land right on the line, but it's going to be reasonably close. And that's what we're looking for, okay? So this just gives you kind of an overview of correlation. I'm not really going to ask you to do any more than this in this course, but at least it gives you an idea of how to interpret what type of correlation you're looking at, how to enter things into the calculator so that you can see the scatter plot, and then what the correlation coefficient might be, at least within a reasonable range.